Have you ever been talking about technology and used the words AI and machine learning as if they mean the exact same thing? It's okay if you have. A lot of people do it. In conversations, on the news, even in big company announcements, these terms get tossed around like two names for the same amazing, futuristic idea. It's a very common mix-up, and it makes sense because they are very closely related. You hear about an AI that can write a song, and then you hear about a machine learning model that helps your phone understand your voice. It all sounds like the same kind of computer magic, doesn't it? But here's the thing, they aren't the same. Not at all. Think of it like this. Have you ever called every fizzy, sweet drink a Coke, even if it's a Pepsi or a Sprite? It's a habit we fall into. We use one popular name to describe a whole category of things. The same thing has happened with AI and machine learning. One is a giant, overarching concept, a huge dream that scientists have had for decades. The other is a specific, powerful tool that we use to make that dream come true. Understanding the difference isn't just for computer scientists. It helps all of us understand the incredible world that is being built all around us, one line of code at a time. It's like knowing the difference between a car and its engine. So, let's get this sorted out, once and for all. It's not as complicated as you might think. Imagine we're on a scientific journey together to explore this amazing field. We're going to look at the big, beautiful map of artificial intelligence and find out exactly where machine learning fits on it. By the end of our exploration, you'll be able to see the landscape clearly. You'll understand why a self-driving car is an example of AI, but the part that recognizes a stop sign is a perfect example of machine learning in action. Getting this right helps us have smarter conversations about the future and what it holds for us. The first step on our journey is to separate these two ideas and look at them one by one. We're going to put on our thinking caps and break it all down, piece by piece. We'll start with the big one, artificial intelligence, or AI. What is it really? What is the ultimate goal that so many brilliant minds are trying to achieve? Forget the scary movie robots for a moment and let's focus on the real science. It's a quest to build something truly remarkable, and once you grasp the main idea, everything else will start to click into place. So, are you ready? Let's go. Alright, let's tackle the big one first. Artificial intelligence. At its heart, AI is a huge field of science and engineering. The main goal? To build smart machines. We're talking about creating machines that can think, reason, and learn in ways that seem human. It's about making a computer that can solve problems on its own, understand language, see the world around it, and make decisions, much like you and I do every single day. AI is the grand, overarching dream of making non-biological things intelligent. It's the big umbrella that covers many different methods and approaches to achieving this incredible goal. It's about simulating human intelligence in a machine. You see examples of AI all around you, maybe without even realizing it. Think about the smart assistants on your phone or in your home like Siri or Alexa. You ask a question, and they understand what you said and find an answer. That's AI. Or consider those chatbots that pop up on websites to help you with customer service. They are designed to understand your problem and guide you to a solution. That's also AI. These systems are built to perform tasks that normally require human intelligence. They are trying to copy how we communicate and solve problems, making our lives a little bit easier. Let's look at another amazing example, a self-driving car. This is a fantastic display of artificial intelligence in action. The car needs to see the road, understand traffic signs, identify pedestrians, and make decisions like when to speed up, slow down, or change lanes. It has to perceive its environment and navigate complex situations, all without a human driver touching the wheel. The entire system working together, the vision, the navigation, the decision-making, is a showcase of AI. It's a machine performing a very complex task that, until recently, only humans could do. This is the big promise of AI, creating systems that can handle complex human-like tasks. So, remember this key idea. AI is the broad concept, the entire field of study dedicated to making machines intelligent. It's not one single technology. Instead, it's a whole collection of different technologies and methods working towards that one ambitious goal. It's like the field of medicine, which includes many different specialties, like surgery, pediatrics, and cardiology. AI is the big category, and within it, there are many different ways to create intelligence. One of the most famous and powerful ways to do that is something called machine learning, which we'll explore next. Now that we understand that AI is the big ultimate goal of creating intelligent machines, let's ask the next logical question. How do we actually do it? How do we make a machine smart? For a long time, one of the main methods was to write a giant set of rules for the computer to follow. Programmers would spend countless hours writing code that said, if this happens, then do that. This is called a rule-based system. For simple tasks, it works pretty well. But what happens when the problem is incredibly complex, with millions of possible if-then scenarios? It becomes almost impossible to write rules for everything. This is where machine learning, or ML, makes its grand entrance. Machine learning is a subfield of artificial intelligence. It's a specific and very powerful approach to achieving AI. Instead of giving the machine a massive detailed rulebook to follow, we do something much cooler. We give it the ability to learn on its own. That's the secret sauce. Machine learning is all about creating algorithms, which are like special recipes for computers that allow a machine to learn from data. It finds patterns, makes connections, and improves its performance over time, all without being explicitly programmed for every single step. Think about how a child learns to recognize a dog. You don't give the child a long list of rules like if it has 4 legs, a tail, fur, and barks, then it's a dog. Instead, you just point out dogs. You say, look, a dog. Over and over again with different dogs. Big ones, small ones, fluffy ones, short-haired ones. Over time, the child's brain learns the general pattern of what a dog is. Machine learning does something very similar. We don't write the rules, we provide a lot of examples, and the machine figures out the rules for itself. So, the key difference to remember is this. Traditional programming is about giving the computer rules to get an answer. Machine learning is about giving the computer data and the answers, and letting it figure out the rules on its own. It's a fundamental shift in how we build intelligent systems. It moves away from the programmer having to know everything in advance, and instead leverages the power of data to create intelligence. This makes it possible to solve problems that were once considered far too complicated for computers, like understanding human speech or identifying objects in a photo. So, how does a machine actually learn from data? Let's use a simple classic example to make this crystal clear. Teaching a computer to recognize photos of cats. If we were using an old rule-based AI system, we might try to write a program with rules like a cat has pointy ears, whiskers, and a tail. But this would fail quickly. What about a cat with its ears folded back, or a cat whose tail is hidden, or a Manx cat, which has no tail at all? It's impossible to write a rule for every single possibility. It would be a programming nightmare. This is where the magic of machine learning comes in. Instead of writing rules, we gather a huge dataset, thousands or even millions of pictures. We label these pictures. This is a cat. This is not a cat. Then, we feed all of this labeled data into a machine learning model. The model analyzes all the images labeled cat and starts to identify the common patterns on its own. It learns about textures, shapes, colors, and the relationships between pixels that together tend to signify cat. It's not looking for one specific thing, but a combination of many features. At first, the machine learning model will make a lot of mistakes. It might see a picture of a small fox and guess that it's a cat. But here is the crucial part. Every time it gets an answer right or wrong, it adjusts its internal parameters. It learns from its errors. When it incorrectly guesses cat, the algorithm tweaks itself to avoid making that same mistake again. After being trained on a massive number of images, the model gets incredibly good. It can eventually identify a cat in a photo it has never seen before with very high accuracy, because it has learned the underlying of a cat, not just a rigid set of rules. This process of training, guessing, correcting, and refining is the heart of most machine learning systems. The machine isn't thinking like a human, but it is learning in a powerful way. This ability to learn from examples is what powers so many of the AI applications we use today. From your email spam filter learning to spot junk mail, to a music streaming service learning what kind of songs you like, it's all based on this same principle. Learn from data, find patterns, and make predictions. It's less about being given a fish and more about learning how to fish. To really lock this difference in your mind, let's use a simple analogy. Think of artificial intelligence as the entire universe. It's vast, it contains everything we know about making machines smart, and it represents the whole grand idea. It's been the dream of scientists and storytellers for a very long time. Within this giant, awe-inspiring universe of AI, there are many different galaxies, stars, and planets. Each one represents a different way, or a different approach to creating intelligence. It's the whole kit and caboodle of smart machines. Now, inside this massive AI universe, machine learning is one very large, very important planet. It's not the whole universe, but it's a major part of it, and it's where a lot of the exciting action is happening right now. It's a specific method for achieving the goals of AI. It's a planet with its own unique environment and rules, centered around the idea of learning from data. It's a world-changing approach, but it's still just one approach among many within the broader cosmos of artificial intelligence. It's a member of the AI family, a very successful and famous member, but not the entire family itself. Are there other planets in our AI universe? You bet. For example, there are rule-based systems, which we talked about earlier. These are like an older planet, one of the first to be explored. There's also the field of robotics, which focuses on building and controlling physical machines that can move and interact with the world. And there are other approaches focused on logic and knowledge representation. All of these are part of the AI universe, existing alongside the bustling planet of machine learning. They are all valid ways to try and build intelligent systems. And to take our analogy one step further, what about deep learning? You've probably heard that term too. Deep learning is a specialized, more advanced type of machine learning. So, if machine learning is a planet, you can think of deep learning as its most prominent moon. It orbits the planet of machine learning and uses a specific technique, called artificial neural networks with many layers, to solve even more complex problems, like understanding human speech with incredible accuracy. So, the hierarchy is simple. AI is the universe. Machine learning is a planet in that universe, and deep learning is a moon of that planet. Let's bring this down to earth and look at how AI and machine learning work together in technologies you use every day. Consider your favorite video streaming service, like Netflix or YouTube. The recommendation system that suggests what you should watch next is a perfect example. The overarching goal, to create a personalized, smart TV guide just for you, is an artificial intelligence goal. The service is acting intelligently to help you find content you'll love, a task that a human friend might do. The entire feature is an application of AI. But how does it work? It uses machine learning. The system doesn't have a programmer writing rules like, if a user likes action movie A, then recommend action movie B. Instead, it analyzes a colossal amount of data. It looks at your viewing history, what you've liked, what you've skipped, what time of day you watch, and compares it to the behavior of millions of other users. The machine learning algorithms find patterns in this data. They learn that people who liked movie X and series Y also tended to love movie Z. So, when you finish movie X, it recommends movie Z. The ML engine is the part that does the learning. The AI is the overall smart feature you experience. Let's go back to our self-driving car example. The whole car is an AI system. Its goal is to replicate the intelligence of a human driver, but it's made up of many different machine learning models. One ML model might be trained specifically to recognize pedestrians. It has been fed millions of images of people walking, running, and standing near roads. Another ML model is trained to identify traffic lights and understand their state, red, yellow, or green. A third ML model might be focused on predicting the path of other cars on the road. All these ML components work together within the larger AI system to drive the car safely. Here's one more: fraud detection at your bank. The bank's goal is to have an intelligent system that protects your money. That's the AI goal. To do this, they use machine learning. An ML model analyzes thousands of your past transactions to learn your typical spending habits. It knows where you usually shop, how much you typically spend, and what time of day you buy things. If a transaction suddenly happens in a different country for a large amount of money at 3 a.m., the system flags it as suspicious. The machine learned your normal pattern and recognized something that didn't fit. The ML model detected the anomaly, and the overall AI system alerted you to the potential fraud. So, we've broken it all down. Artificial intelligence is the big, ambitious goal of making machines smart like humans. Machine learning is a powerful method we use to get there, by teaching machines to learn from data instead of just following pre-programmed rules. AI is the whole spaceship. ML is the amazing engine that makes it fly. Knowing this difference isn't just a fun fact for a trivia night. In 2026, understanding this distinction is becoming more and more important for everyone, not just for the scientists and engineers building this technology. For anyone in the business world, knowing the difference helps you make smarter decisions. When a company says it's using AI, you can now ask, how? Are you using machine learning to analyze customer data, or is it a rule-based chatbot? This clarity helps you understand what a technology can actually do. It helps you see past the marketing buzz and evaluate its real potential. As more and more jobs involve working alongside smart systems, being able to talk about them accurately is a valuable skill. It's the first step toward understanding how these tools can help you in your work. As citizens, understanding this helps us have more informed conversations about the future of technology and its impact on society. When we discuss the ethics of AI, it matters whether we're talking about a simple rule-based system or a complex machine learning model that learns from biased data. Knowing the mechanics helps us ask better questions about fairness, privacy, and control. It moves the conversation from a vague fear of robots taking over to a more productive discussion about how we want to design and regulate these powerful learning systems for the good of humanity. So, there you have it. The mystery is solved. You now know the real difference between artificial intelligence and machine learning. AI is the grand vision, and ML is a brilliant technique for making that vision a reality. They are partners, not rivals, and certainly not the same thing. The next time you hear someone use the terms interchangeably, you'll know what's really going on under the hood. You've peeked behind the curtain and seen how the magic really works. And in a world that is changing faster than ever, that kind of knowledge is a true superpower. Consider yourselves enlightened.